The hope that someone paralyzed for years by a severe spinal cord injury would ever be able to walk again was just that hope. People afflicted with spinal cord injuries, schizophrenia, autism, and a host of other neurologic conditions have a few far options. However, today a new technology suggested by Neuralink have the potential to solve some of these problems. The company of Neuralink is planning to implant threaded electrodes inside the brain in order to sense the neuron signals and stimulate them more effectively and more accurately. Reading and stimulating our neurons would open the door to several fascinating applications, including treating many neurologic diseases. Neuralink is developing a brain-machine interface, or BMI, that aims to help the paralyzed people controlling computers, using robotic limbs, or even restoring their own body ability to move, talk, and see again. Neuralink is planning to implant electrodes inside the brain to read the information that neurons send in forms of electrical signals known as action potentials. When you think about walking, for example, your neurons send signals to your legs muscles, telling them to contract and relax so you can walk. People with spinal cord injuries cannot walk because the neuron signals cannot be received by legs muscles. And the main reason is that the neural circuit has been cut when the spinal cord got injured. In order to let spinal cord injuries patients be able to walk again, we need to read the neuron signals and send them to the legs to direct them to move. More importantly, we need to sense the leg signals and send them to the brain in order to get a feedback. If we could relink the neural circuits between the brain and the muscles, we can finally get a balanced movement pattern. So, how to read these signals? The neurons of our brain connect to form a large network through axon dendrite junctions called synapses. At these connection points, neurons communicate with each other using chemical signals called neurotransmitters. Neurotransmitters are released from the end of an axon in response to an electrical spike called an action potential. When the cell receives enough of the right neurotransmitter input, a chain reaction is triggered that causes an action potential to fire and the neuron to in turn relay messages to its downstream synapses. Action potentials produce an electric field that spreads from the neurons and can be detected by placing electrodes nearby, allowing recording of the information represented by a neuron. Neuralink's brain-machine interface, or BMI, can track the spikes in the real time. There is no wearable that can track the spikes because you need to be under 16 microns away from the neuron for tracking. Implants are not a new thing. There is actually a history of implants dating back to 1957. What makes the Neuralink's implant incredible is that super tiny chip that contains over 3,000 threaded electrodes that will allow us to record a higher volume of real-time data from neurons as they fire. In contrast, some current BMIs have up to about 100 electrodes. Let's take a look at the other implant technologies. One is called the Utah Array, the other is the Deep Brain Stimulator. In the Utah Array case, the rigid sharp metal electrodes produce a fairly strong immune response, which means that we will lose the ability of recording single spikes over some period of time, usually between 1 and a couple of years. Deep brain stimulators solve a different type of a problem. They are effective for some of Parkinson's patients, and they have only a couple of electrodes that inject large amounts of current but not record single spikes. However, the flexibility of the Neuralink's threads makes it harder to insert. To overcome this issue, Neuralink also announced a remotely operated neurosurgical robot capable of inserting 6 threads per minute. The surgical robot is under the supervision of a surgeon as electrode threads are implanted in tests. With the robot-assisted surgery, Neuralink implants implanted this tech while minimizing bleeding and reducing the risks of harming critical vessels. So, the implant is definitely capable of reading neural signals. Well, that's great, but how the surgery will be done? A Neuralink likened the surgery to LASIK. No big scars, no hospital stays, it would be a shorter procedure, and you get to keep all your hair. You got a local anesthetic, a small opening is made in the skin, a painless opening is then made in the skull below. After that, there is a quick placement of the electrode threads. Then the hole in the skull is filled with the sensors. The skull is finally closed up. In tests, the total insertion time averaged 45 minutes. Then behind the ear, a small incision is made for a coil. The surgeons will tunnel tiny wires to connect the coil to the sensors. A sleek battery-powered computer sitting behind the ear will communicate with the implanted chips connected to 4 different areas of the brain. It might even be controlled by an app. Some of the uses of BMIs are obvious. Paralyzed people could control wheelchairs with their minds instead of a joystick. Those who have lost their limbs could have a connection to a robotic arm they can manipulate. Neuralink envisions their threads of electrodes not only being used to detect brain signals, but giving feedbacks as well. When people who lost their limbs get sensory feedbacks, they will be able to deal with their robotic limbs as if they were their real limbs. The paper that Neuralink has published says that in the future, this approach could conceivably restore motor functions, which means we might be able to restore paralyzed people's abilities to control their own bodies. More interestingly, this technology will change the way we interact with the outside world in a spectacular manner. Right now, the way your brain communicates with the outside world is pretty limited. If you want to talk to someone or a computer, for example, you've got your mouth for speaking and your fingers for typing. That's it. However, soon, and with the Neuralink's coming technology, you might be able to send informative signals to your friend's brain directly from your brain. You might also be able to share each other's thoughts without even using words or physical expressions. Elon Musk, the founder of Neuralink, has fears of the dangerous outcomes of the artificial intelligence. He said, "So the rate of improvement is really dramatic. We have to figure out some way to ensure that the advent of digital superintelligence is one which is symbiotic with the humanity." I think that is the single biggest existential crisis that we face and the most pressing one. By allowing our brains to interact directly with the artificial intelligence by using BMIs, Elon Musk hopes to make the human relationship with the artificial intelligence a symbiotic one. As it was said, if you can't beat them, join them! Thank you for watching, guys. Sumaya Abdulaziz was with you from her house institution for spectacular scientific news.